want to get to some of these other product lines, and the gravimetric feeders. Now, I'm familiar with feeders. When I see gravimetric, I don't know if I'm still picturing just a regular feeder, but then I'm seeing a. So maybe I'll let you explain what we're looking at. We'll bring it up on the screen, and then just walk us through it.
So a gravimetric feeder, what we mean, Tecweigh means by gravimetric feeder, we could call it a gravimetric screw feeder or
Mm.
auger style feeder. And what that's doing is it's controlling the flow rate based upon, for example, like the loss in weight. So yeah, so you could have a volume, or sorry, a gravimetric feeder. It's either doing a batch or it could be continuous and what's called a loss in weight. And I'll let Michael explain, about batching and loss in weight. I think that would be very, very useful. But I'll just mention about the application. Usually the gravimetric feeders of this nature are for dosing some sort of ingredient in a recipe,
Mm.
and that recipe could be for making cement, could be for making wallboard, some sort of construction material, an additive, dosing additive, in those kind of things, and where it needs to be very critical that it is the correct amount that is fed into there. And I'll turn it over to Mike.
Yeah, just to expound on that a little bit, the gravimetric feeder is basically the biggest difference between gravimetric and volumetric. Gravimetric's got load cells, volumetric does not. And the gravimetric is, and we've been working really hard. We have a new controller on the market for that. It's a TT20 that we've done a lot of work on. We've had really good luck with it out in the field. We've one that comes to mind is that is we have I think 10 at a composite decking facility. And they call it dirt, but it's actually calcium carbonate that they're adding to the decking, and they want it to run at a certain rate. So say we with different screw and auger and feed tube combinations, our controller, the customer can tell it, we want to run 10 pounds a minute out of there. So that creates a PID loop where our controller is controlling the motor speed based on the loss of weight. So it's basically it's constantly sampling how fast is the weight leaving this vessel. I either need to speed up or slow down the auger based on the rate that the customer wants to run. The other part of this is the volumetric feeder. They know the rate that they want to run, and it's never, and they're not want to change it. So generally what they do with the volumetric feeders, when they get that on site, they'll run the motor at a couple different rates, and they'll sample it, and they'll say, okay, we know when the motor runs at 20%, we're doing 10 pounds a minute. We know at 40%, we're doing 20 pounds a minute. So then they kind of extrapolate that out. That says, okay, it's good enough to run at just 15% constantly, and we're going to get this rate, and we don't really care about the weight feedback. So it's a little more coarse. It does the same thing, but it's a little more coarse. You won't quite get the accuracy on a volumetric that you would on a gravimetric. Those are loss in weight. Now, the other part of what we can do with the gravimetric is we can do a gain in weight. So the feeder actually doesn't have a scale, but there's a scale in the vessel that it's feeding into, and it can fill to a certain capacity. So say you want to run just 100 pounds out of our feeder into a keg, and you're packaging. We do this for the steel industry. We run, for different additives they add when they're making steel. They do it in like 50-pound sacks. So we basically run 50 pounds out into a bag, and then they put it into the sewing machine, throw another bag underneath, and just repeatedly do that. The other part of that is a batch loss of weight. So that goes back to the feeder having load cells, and just says we want to use the feeder to look at when we dispense a certain weight, like say 50 pounds, and then it stops instead of the continuous loss of weight.